Hello Math 3 students, this video is for your Unit 1 test review. As I go through each of the sections, if you'll notice up at the top, I'll put the lesson that this section correlates with, as well as the page numbers in your notes, so you can go back and look at that if you need to. So as you can see, our first section is from Lesson 6 and Lesson 8, and it covered page 15 and also pages 19 through 23. I'm going to go over, and this is our function up here, I'm going to go over to Desmos and graph this function and talk to you a little bit about graphing functions on Desmos. First of all, you really don't have to enter the f of x or the g of x unless you're graphing a horizontal line, such as y equals 5 or y equals 3. Then you would want to enter y equals or f of x equals or something like that. So you don't have to do that, but you can enter it every time. If you do, before you type in the rest of it, it's going to ask you to add slider. Don't do that. Also, make sure that you use a lowercase x and not a capital X, because it won't graph it if you use a capital X. I also want to make sure that you know where your absolute value key is. It is, on mine, it is the backslash, it's shift backslash key. It's above the enter key. You can also find it down here on the keyboard. You can pull that up and find it, and I think it's right there. It's hard to see because I've got it cut off down here at the bottom. So you can find it there, but I think it's easier to type shift backslash. So let me enter the rest of this. Also, when you enter a fraction, you can hit the / button and it will create the fraction. To get the cursor back out from under, out from the denominator and back up here, just hit tab and it'll bring that back up. Let's see, -4. So I've got my function graphed. I want to make a couple of notes before I go sketch it. I have a vertex at -6, -4. I have a x-intercept at -8, an x-intercept at -4, and I also have the y-intercept at 8, 0, 8. So just making notes of that, and then I'm going to go back over here and sketch it, because you will be expected to sketch this. So let's put our points here. So our vertex was at -6, -4. We had an x-intercept at -8, 0. We also had an x-intercept at -4, 0. And we have a y-intercept at 0, 8. So just want to mark those points, and then I'm going to use my line tool. You can use a ruler. I have rulers in my room. If you need to use a ruler to do this, you can. You can also just sketch it. I'm going to look to see that you knew where the vertex was, where the x-intercepts were, and where the y-intercept was. So I can't bring that all the way up like the other one. I also want you to put arrows on it. Okay, so there's our graph. If you if you also go ahead and mark these points, it'll help you to do the key features as well. Okay, so these are not in exactly the same order, or yeah, they're not in the same order as the ones that we did for the classwork, but we will start with the same place I usually start, which is vertex. So I always start at vertex. Vertex is -6, -4. The line of symmetry matches the x value. The slope here, well, let's see. Well, the slope is going to be 4 times the absolute value of 1/2 is going to be 2. I can also check it here. I can count up 2 over 1, up 2 over 1. So I know that the slope is 2. It has a minimum. I'm not asking what the minimum is or what the maximum is. I'm just asking, does it have a minimum or a maximum? The x-intercepts, I would like to see the ordered pair. The y-intercept, 0, 8. Okay. And then the increasing interval is on the right side. And remember, we're just looking at x values, so it goes from -6 to infinity. And then the decreasing interval comes from -infinity to -6. The interval where f of x is positive, there is just part of it that's positive. It's not the whole thing. So we'll mark where it's positive is, remember, above the x-axis. So it's going to be two intervals. The first one comes from -infinity and stops at -8. Our or symbol, and the second one starts at -4 and goes to infinity. I'm trying to get that infinity right. It looks really weird. It's hard for my pen to draw the two little circles. So, all right, interval where f of x is negative is down here underneath the x-axis. This teal part, which as far as the x's are concerned is actually this interval right here. So it's from -8 to -4. And then the last thing we want to do is look at the left end behavior and the right end behavior. Remember, we're just looking at the arrows on this. So the arrow over here on the left points in an upward direction and in a left direction. That is a positive and a negative. So we would state, and I think I'm going to move this up a little bit because I have a hard time down at the bottom of this tablet. So we would state that y approaches infinity as x approaches -infinity. And then on the right side, and I changed it to left and right because I think we should do left and then right. It's pointing up and to the right, so that's positive, positive. So next section, number 2, state the parent function and the transformations for each of the following. So this first function is a quadratic, which means that the parent function is y equals x squared. And
please come to the lobby.
Sorry. So kind of the expanded version of that is the x minus h and then squared plus k. So this minus 1 is the plus k. So the transformation is that it's down 1 in it. So the parent function, I don't care if you put all this, you can put y equals, it's fine, would be absolute value of x. And the transformations are, it has a vertical stretch 2, it moved to the right 1, and up 5. Just a reminder to do the left and right, look at the vertex. Don't excuse me, don't just look at this number right here, because if there is a b value, you're going to need to set this equal to 0. So if it was like a 2x minus 1 or a 2x minus 2, you would need to set that equal to 0 and then look at that to determine the left and right movement. Okay, so part C, again, this is an absolute value. So parent function, absolute value of x. This one, again, it doesn't have a b value, so it's really easy to do. It moves to the left 5 and down 2. Okay, and then the last one is a square root function. Parent function would be square root of x, and it had 2 transformations, and the first one is reflect over x-axis. And the second one is a vertical stretch. I'm going to move this up so it's a little bit easier to write. Vertical stretch 3. Section is the same as the one before. Part 3 is the same as part 2 as far as the section of the notes in the lesson. All right, part 3A. They are asking us to actually write the equation of the function with the given transformations. So they gave us the transformations, and they're asking us to write the function. So let's see, square root, parent function would be square root of x, and then left 3, and then right 2. So I can go ahead and write, let's just put y equals square root of x plus 3 minus 2. Next one's absolute value, reflection over the y-axis. Now this is a horizontal thing, so this is part of the b value. And then the horizontal stretch of 2 means that the b value is going to be 1/2. So I'm just going to make a little note. B is going to equal 1/2. And the negative, this reflection over the y-axis, is going to show up inside the absolute value. So this is going to look like this. Y equals, and then we have an absolute value, and then negative 1/2 x. I think that's it. Yep, that's it. Okay. So reflection over y-axis, the negative goes inside the absolute value. Over x-axis, it's going to go on the outside. So that's what this one is, reflection over the x-axis. So we're going to have a negative a. So there's going to be a negative there, and then x minus 9. And no value out there, no k value. Lesson 9, Piecewise Functions, pages 24 through 27, is actually going to cover the next 6 slides. So numbers 4 through 9 would all be from this section. Okay, number 4. We are asked to write the piecewise function for the graph. So I want to just make a couple of notes. First of all, the part of the graph on the left is a parabola. The part of the graph on the right is linear. Let me grab a pen. Okay. All right, let's see. So I'm looking at this parabola and I'm thinking, okay, this looks like the parent function parabola. And if I check x squared, 0 squared is 0, 1 squared is 1, 2 squared is 4. And so yeah, this is the parent function. So I know it's just going to be x squared. So looking at that, I can start my piecewise function by stating that this side right here is just x squared. And then my domain restriction on this is going to be x is less than. So if I were to, define that dividing line, it's right here for both parts of the graph. It's less than or equal to 1. So where x is less than or equal to 1, it equals x squared, because that's that parabola. And then this one over here is going to be x is greater than 1, because you've got an open circle there. And the function for this one, first of all, I can look and see, okay, the slope for this is a positive 2. Okay, so I know it's going to be 2x something. Well, 2 times 1 is 2, plus 1 is right there, 3. So let's check another one. 2 times 1 is 2, if I didn't say that. 2 times 2 is 4, plus 1 is 5. So it looks like it's 2x plus 1. I can't tell where the y-intercept would have been, but if I did keep that going, it looks like it would have been at 1. So that kind of double checks it for me. And then this would be x is greater than 1, because it's an open circle at 1, 3. So this is the answer right here to this one. The next one, okay, so this time we have a 3-part piecewise function. We haven't done any of this, but I thought it would be interesting to put it on here and to see how we do on this. Now yours has arrows, and I did add those arrows, and so I'm going to add them here and here. Okay. Okay, so let's look at the middle part first. The middle part is pretty easy. The middle part is y equals 4. So let's just put a 4 here. And that is if it is between negative 1 and 1. So I'm going to write that as negative 1 is less than x is less than 1, because what that says is if x is between negative 1 and 1, and those two are not included, then y equals 4. So that's that straight line. Okay, so the one over here, what I see here is I see that first of all, it has a slope of 1. Okay, so I know I'm just going to have an x. And then let's see, what else can I look at? Negative 1, and it's just going to be an x. Negative 1 plus 5 is 4. Okay, so let's check that out. Yeah, if it was x plus 5, would that work? Well, negative 1 would be at 4. Yep. Negative 2 would be at 3. Okay. Negative 2 is at 3. Negative 3 is at 2. Yeah, that works. So it's x plus 5. And again, I can't see. Yeah, I can. I can see that would be at 5. So my y-intercept would be at 5 also. Okay, so it's x plus 5, and then my domain restriction is that x is less than negative 1. Okay, so the last piece of this graph has a slope. I'm just going to make a note. Slope negative 1. So that means I'm going to have a negative x here. Okay. All right, so let's see. At 1, the graph is 4. At 2, the graph is 3. And it looks like my y-intercept would have been at 5 also, because the slope, it just goes like that. So it would have gone through 5. So it looks like this one is negative x plus 5. And this would be where, let's see, x is greater than 1. So if we looked at the domain on this one, you're not asked to look at the domain on this one. The domain here would be negative infinity to negative 1, not included. And then negative 1 to 1, and those aren't included. And then 1 to infinity. That would have been an interesting domain. Okay, on to the next one, number 6. So this is a two-part. It almost looks like a 3-part. And again, you had arrows. I'm just going to put this in green. You had an arrow right there, because I didn't want it to stop. I wanted you to do this with arrows. So let's see. This looks like the parent function, absolute value function, but it's been reflected over the x-axis and it's been moved up 3. So what does that look like? Well, it's a negative right there, reflected over the x-axis, up 3, and that's it. And this one is x is less than 2. Okay, this one is linear. The slope is 1, 2, 1, negative 2. So I know it's negative 2 something. Now, there's a lot of different ways we can figure this out, but I'm just going to say, okay, if the slope is negative 2, then I would go up 2 over 1, up 2 over 1. So my y-intercept would have been positive 2, so it's plus 2. And then that would be where x is greater than or equal to 2. All right. Our next section is still piecewise functions. We're asked to do several things. We're asked to graph it. we are asked to identify whether or not it's a function, so circle yes or no here, and then evaluate several different values from the piecewise function. So let's graph it first. Let's start with the fact that we have a dividing line at -2. I'm not going to draw this line every time, but we have a dividing line at -2. This is going to be an open circle. I'll do this one in red. This is -2, and -2 plus 5 is 3. So I'm going to have an open circle at -2, 3. Right here. All right, and then what I need to do is figure out where the rest of this graph goes. I know that it's going to be over here on this side of the -2. I know that the slope is +1. So if I could do that, or I could pick another, like I could pick -3, -4, whatever. If I pick -3, -3 plus 5 is -2. So -3, sorry, +2. Right, here's another point. -4 would be 1. I also could have just gone 1, 1, 1, 1 like that, and that would have worked too. So this graph goes from here this way, and we got an arrow at the end. Okay, the other one, and I'll do this in a different color. I'll do this one green. The other part starts at -2 again. This one is a colored in circle. -2, and let's see, that's -2 times -2 minus 1. That's 4 minus 1, so that's 3 again. So -2, 3. Let me make sure on my key, yeah. So I'm going to go -2, 3, and I'm just going to color that in. Sometimes that happens where you have an open circle and a closed circle at the same place. And then what else do I know about this one? I know that the slope is -2, so I could go down to right 1. And down to right 1 again. And that would give me that line. I could also just plug in like a -1, a 0 would be good, because -2 times 0 minus 1 is -1, and that's where that is. Okay, so there's that one. All right, is it a function? Yes, it's a function. It doesn't have any, even though there's an open circle and a closed circle here, there's not two closed circles. If there were two closed circles, it would not be a function. Now we need to figure out, what is f of 3? Well, I can't go to the 3 on the graph and figure out what that's going to be. Figure out what that's going to be, because I didn't go that far with my line. Even if I had, it might not have been very accurate. So I need to go up here and figure out which domain restriction, red or green, does 3 fit into. Well, 3 is greater than -2, so it fits in this one. So what I'll do is I'll plug in the 3, -2 times 3 minus 1. So what is that? -6 minus 1, so that's -7. Okay, I'll do the same thing with the -4. -4 is less than -2, so that's the red one. So -4 plus 5 is 1. And then the last one is -2. Let's see, -2 is equal to -2, so that goes with the green one also. -2 times -2, and then minus 1, and we already actually did that one, didn't we? So that's 4 minus 1, so that is 3. So number 8, I decided to go ahead and draw my dividing line. My dividing line is at 3. Both of these have a domain restriction that has to do with that 3 line. So let's see, the first one, I have a closed circle. I'm doing kind of a maroon color for this one. That's at 3, -3. And this says y equals -3. So no matter what x equals, y equals -3. I'm going to put my closed circle at 3, -3. And then that graph, that part of the graph, is going to be from here, and it's just a horizontal line that way. Okay, let me get a different color. Let's do this one. So this part of the graph starts at 3, and it's an open circle, and it's going to be 3, and then let's see, 2 times 3, 6 minus 5, 1. So I have an open circle at 3, 1. So it is still a function because I have an open and a closed in the same vertical line, not two closed. This one has a slope of 2. Now, you can do more x values if you want and plug them in, but for me, I just say, okay, the slope's 2, so I'm going to go up 2 to the right 1. And then I'll do that one more time. So there's my other part. I'll put an arrow at the end. We might be able to look at just the graph and tell what f of -4, f of 0, and so on. Let's see, f of -4, of course, if I go over to -4 on the x-axis and I look and see where it matches up, well, that's going to be right here, because on this side of the graph, every y value equals -3. So I don't really have to do the math on that. It's just -3. Same thing for f of 0. Still goes to -3. And f of 3, guess what? That one still goes to -3 also. So all of these were on that part of the graph where y equaled -3. Okay, last one in this section, we need to graph this piecewise function. This is another two-part piecewise function. So I found this pink color. I like this. It's close to Valentine's Day, and it's my birthday, and I like pink. So I found a pink color to draw this dividing line on this one. So the dividing line is at 1. All right, so let's get started. I'll do a green here. Closed circle at 1. 2 times 1 is 2, plus 1 is 3. So at 1, 3, we have a closed circle. This one's linear. We know that it's on this side of the graph. They kind of did it backwards. So it's on the right side of the graph. It has a slope of 2, so I'm going to go up 2 to the right 1, up 2 to the right 1. So there's that part. Be careful that you look and see which side it's on. The other side is going to be to the left of the pink line. I'll do purple this time. This is an open circle. This is going to be at 1, and let's see, 1/2 minus 3 is -2.5. So I'll just put -2.5 there. So at 1, -2.5, 1, 1, 2, there's about 2.5 right there. So I got, that's not very good, but anyway, it's supposed to be at -2.5. There's an open circle at -2.5. Okay, I know, weird pause here, but I thought I had made an error, but I had not. So -2.5 is correct. We can look at the slope. The slope here, this is the same as 1/2 x. So the slope is 1/2. So if I went down 1 and over 2, that would give me another point right there. Or I could plug in maybe a 0 for an ordered pair. So then that would be 0 divided by 2 minus 3. That would be -3. So 0, -3 would be another point. 0, -3. And, that kind of looks like it's in the same line right there. So I'm going to go with that and just trust that I've done this correctly. So it's going to go from there, kind of like that. Then put my arrow here. Okay, so that's what that function looks like. Is it a function? Yes, this one is also a function. And then f of -2, maybe I can look at the graph and yeah, I can see what that is. -2 is -1, 2, 3, 4. So I can just look at that. I don't even have to do the math. Just look at the graph. F of 6, yeah, I can't look at that because it doesn't go up high enough, so let's go ahead and plug that in somewhere. That is greater than or equal to +1. So that's going to be 2 times 6 plus 1. 12 plus 1 is 13. And then f of 1, I can actually look at that one and see where that one is. That's at 3. So I don't need to do the math on that one. Okay, so this next section, 10 through 12, is from Lesson 5, Inverse Functions, and it's pages 10 through 12 in your notes. So if you want to graph an inverse function and you don't know the function rule, which this one doesn't really have a function rule, So what we need to do is we need to find the ordered pairs and just switch those ordered pairs. So let's do that. We have an ordered pair. Let me get a pen. We have an ordered pair at -3, 1. I'm just going to list them. -3, 1. Then we have another one at -3, 3. And then another one, the last one is at -1, 4. So if we want to graph the inverse of this, if you remember way back when we did inverse functions, we found out that inverse functions have reversed x's and y's. So my first ordered pair is going to be 1, -3, so just switching this around. And then 3, -3, and 4, -1. So we'll just plot those points and then join them, and that will be the inverse of this function. So it turns out the inverse of this function, actually this isn't a function, the inverse of this is a function. This is not a function because it doesn't pass vertical line test. Next one, number 11. We need to figure out what these points are. This one's at -2, 2. And let's see, -4, 2. And -3, 4. So there's that. I can try to make a circle. I don't know if I can or not, but I can. That's not the middle of them. Let's see. That's a little closer. Okay, something like that. And the last one. This one's just got a few more points. Okay, to save a little bit of time, I just went ahead and listed those points, and then we can just do backwards. We don't even have to list them again. So 1, -6, 4, -4. These are so hard to see. 1, 2, 3, 4. So those would be joined. 4, -1. 1, 2. Oh, I'm sorry, 2, 1. And the last one's 2, 4. Okay, so that's what that one looks like. This section is also inverse functions, and it's finding them algebraically. And I think if you remember, you can check on Desmos to see if the function is if the inverse is a function. Sorry, I'm getting tired. All right, so let's change this to a y. We'll switch the x and y, and then solve for y. Add 3, divide by 2. If you remember me telling you that you're not going to see it like this on an exam, what you would see is 1/2 x plus 3/2. So this is what I would like to see over here, and I would like to see the inverse notation as well. Is it 1-to-1? In other words, is its inverse a function? This is also a function. It's linear, so your answer would be yes, it is 1-to-1. So number 14 is a little more fun. Let's switch or change this to a y. Switch that and the x. So I'm going to write that over 1. I'm going to do cross products. So x times y equals y minus 5. And then I'm going to subtract a y from both sides. So that would, over here on the left, that would be xy minus y equals -5 on the right. And then I'm going to factor out a y, because I can pull a y out of here as a greatest common factor. -1. And then I can divide by x minus 1 to get y by itself. And it's fine if you just leave it like that. I do want you to do the notation over here though. And this one is also 1 to 1. Its inverse is also a function. I'm not even sure what just happened, but anyway, we're on number 15. So we'll go ahead and switch the x and the y there, add 4, and divide by 5. Answer is yes. This is also a function. So number 16 is from lesson 2, way back at the beginning, and this was the quadratic review on page 2. It was pages 1 and 2, but the quadratic part was just page 2. So I think I told you that this didn't show up very well on your unit, on your test review. So I told you where you could find the picture of this on Planbook. I shared a file with you. So in looking at the file, you can see where the different points are. So we can see that the vertex on this is at -3, -1. And notice too that we're told to write this in standard form, so we need to not leave it in vertex form. But we're going to write it in vertex form to begin with. Using the vertex, we're going to write y equals, and you know we have that a value, we don't know what it is yet. We have x plus 3 in parentheses, quantity squared, and then -1 outside the parentheses. So what we're going to do is we're going to use another point on this graph to find the a value. There are 2 points that I can see that look like they're pretty good ones. One of them is right here, and then another one is right here. I'm going to use this one down here. This is -1, -5. So I'm going to use -1, -5 to plug in for x and y so that I can find the a value, so that the a value is the only thing that I have that's unknown, so I can solve for that. So I'll put a -5 in for y, and then a -1 for a, and then I'm sorry, for x, and then I will solve for a. So now I have a two-step equation. I'm going to add 1 over here, -4 equals 4a, and a equals -1. I kind of knew that because this looks like parent function and it's pointing down, so I figured it was probably going to be -1, just wanted to make sure. So now I can rewrite my equation, putting that -1 in, but I'm not finished because I've been asked to write this in standard form. So what I need to do is multiply all this out. I'm going to leave that negative until I get this part done. So x plus 3 quantity squared is x squared plus 6x plus 9. And on the outside of the parentheses, I still have that -1, but I need to distribute this negative in here and then add that -1. One more step, just got to add the -9 and the -1. And this is standard form. Now on your test, be aware you might be asked to leave it in you might have to be asked to put it in intercept form, vertex form, or standard form. So be sure you know what all three of those look like. So 17 through 20 is lesson 6, AV equations and inequalities, solving these algebraically. So we're going to solve these algebraically. So 17 and 18 are equations and 19 and 20 are inequalities. So if you remember, first thing we want to do is get the absolute value part by itself. And to do that, we kind of treat it as though it were a variable. So we're going to divide both sides by 2 here. And we end up with absolute value of x minus 3 equals 3x. And then once we get this isolated, that's when we separate it into two different equations. I'm just going to warn you, if you see one where you've got a variable on this side, you want to definitely check your answers and see if they work with this. You could also go and graph this and see if both of the solutions are where these two intersect each other. So let's see, I'm going to subtract x here. Negative 3 equals 2x. Divide by 2. X equals negative 3 halves. So on the other side, I'm going to subtract x again. So x equals 3/4. So two different things you can do. You can double check these in the original equation, the original absolute value equation, or you can go over to Desmos. You can graph each side, which is what I did here. Look for the points of intersection, and I'm going to just zoom out so you can see that there is only one point of intersection for these two parts of this equation. And it is at 0.75. And when I go back over here, I see that 0.75, I do have that one, but I also had a negative 3 halves. That one doesn't work though. So what I want to do is just cross this one out and say, nope, that one doesn't work. This is my only solution. So there's only one solution to this equation. All right, the next equation, we are going to solve algebraically again. There's only a few of these. So add 9. Divide by 6. Now I separate it. Okay, so I got negative 2 for that one. Okay, and then I got negative 2 and 8/3. I'm going to go over and graph it and just double. So there is something I wanted to show you about this. Now there are 2 points of intersection. We're going to look at this in a minute. But this original equation had a b in it. And if you put a b in these on Desmos, it's not going to graph for you. You're going to have to put an x in there and not a b. So we do have points of intersection at negative 1.75 and 2. So let's see. Let's go back over here. 8/3. Let's see. Was it negative 2? No, it was 2. I must have entered something wrong. Let's see what I did. Negative 9 plus 6. Negative 3x plus 1. And g of x equals 33. Oh, I see what I did. I didn't put the equals right there. Let's see what we've got now. Negative 2, which we did get, and 2.667, 8/3 is what? 2 and 2/3, and that would be 0.666. So these both work. So your answer would be -2 or 8/3. All right, and this one is an inequality. So we need to isolate the absolute value before we decide whether it's an and or an or. So let's add 10. Don't be fooled here and add these two together. You're going to add positive 10 over here. So this is going to be an or statement. Now, when I divide by -10, don't forget you have to switch this. And then that's going to be a -2. Same thing. Switch that to greater than. A is greater than 2. Okay, and so that would be an or statement if you thought about it on the number line, less than -2, greater than 2. So we would just say S is less than -2, or not S, A is less than -2, or A is greater than 2. So you could write it like this. Oh, you were asked to put it in interval notation, sorry, if it was an inequality. So your interval notation would be this with parentheses, and parentheses again. So that would be your interval notation. So you would actually answer it that way if it asked you to do that. Okay, so again, I want to caution you that you don't want to look at this and decide whether it's an and or an or before you isolate the absolute value, because we have to divide by -2. And when we do that, this becomes a less than, and this is a 2, and so this is an and statement. It's a less than, so it's an and. So let's see, M is going to be less than 8, and M is going to be greater than, that's going to be a 4. So if we do this in interval notation, it's just parentheses 4, 8. If we did it in inequality notation, it would be that. Okay. All right, so we're done with the algebraically ones. All right, so number 21 through, let's see, actually the last one, numbers 21 through 25, was the lesson, what was it? Lesson 10. I'll just write it up here. Lesson 10, which was the, not the honors, sorry, the AV equations and inequalities solving graphically. And so this was pages 28 through 30. All right. So I went ahead and graphed these on Desmos and did a screenshot so it would be easier. So I graphed this part on one of them and this part on the other one. And remember, we are not looking at y values, so I'm just going to mark that out. We are looking at points of intersection, and that's it. This is an equation. So with equations, we just look for the points of intersection. There are 2 of them, so I would answer -2 or -1. That would be the answer to that one. Number 22. Again, this is an equation. I'm looking at just the points of intersection. There's only one point of intersection here, and again, we don't pay attention to that. The one point of intersection is -1, so that would be my answer to that one. Number 23. This one is an inequality. So what I want to look at is the parabola. The red one is this part right here, and then the blue one is this part. So I need to look at, it says red is greater than blue. So what part of the red is greater than blue? Now we need to understand that there was more to this. There is more to this. So it's like this, okay? So it is a parabola. It just goes up further, and I just cut part of it off. I'll mark out the y's, because we're not looking at y's. So what part of the red graph is greater than or equal to the blue graph? So on this one, this is 23. Yep, we got a -2 and a 4. I just want to check my key just to make sure I got I answered it the right way on here. Yep. So I'm going to highlight this. This is really similar. If you thought about this blue line as just being a straight line across here. In fact, let me do that. So if the blue line was a straight line, like that, then what part of this red graph is above it? That's what we're looking for. It's going to be from here to here, which as far as x's are concerned is from here to here. So it's just one interval, and that interval is from -2 to 4, and it does have brackets because it has the equals marks. Okay, 24. So this is another inequality. So I had entered something wrong. I'll try to cut that part out, but I had entered something wrong, I guess, when I graphed them the first time. So I think I have it right now because it matches my key also. So what I'm looking for is the section of the blue graph that is below the green. So that's this part right here, and I'm only looking at the x's. So my interval is going to be -7 to 1, and it's less than, there's no equal. So let me go back over here. Oh, I know what I'm doing, sorry. So this should have been, if I had graphed it correctly, this would have been a -7, and this would have been a 1. And so my interval is parentheses, -7 and 1. Okay, the last one is an inequality, and is a system of inequalities, and we are instructed to write the the function rules. So what you need to know is that this is going to end up being two different inequalities that are called a system. So it's two inequalities in your answer. So let's look at what we have. We have a parabola, and we also have an absolute value function. And the part that's shaded, the darkest, is our system of inequalities solution. Okay, so let's look at the parabola first. Okay, we'll do the one that's, I think, most difficult first. So what do we have on this parabola? We have a vertex right here. So we'll mark that. So our vertex, here's my origin. Our vertex is 1, 2, 3, 1, 2, 3, 4, 5, 6. So our vertex is 3, 6. So I'm going to make a note of that. And if I write this in vertex form, I can use that vertex. So it's going to be y equals, and then I have the a value, I don't know what it is, x minus 3, quantity squared, plus 6. I can find the a value because I can pretty much tell that there's also, let's see, what else do I have that I can see? 5, 2. Yep, I can use 5, 2. So let's use 5, 2 to find what the a value is. I know it's going to be a negative because it opens down, but I don't know exactly what it is yet. So let's see, let's put a 2 in for y, and we'll put a 5 in for the x, and then we'll solve for a. That's going to be 2 squared, which is 4, plus 6. Okay, so let's subtract 6 over here. That's going to be -4 equals 4a. So a is -1 again, just like it was in our other one we did. So my y, we'll call this f of x. Okay, so we'll call the red one f of x. Okay, so what this is then is, because it's the part that's below the f of x, it's going to be less than, and because this is a solid line right here, or solid outline right here, this is less than or equal to. If it was a dashed line or a dotted line or outline, then it would be just less than. But this is going to be, we'll do, you know what, instead of f of x, let's do just y sub 1. Okay, so this is going to be y sub 1 is less than or equal to, and then we'll just put our original equation with our -1. So negative x minus 3 quantity squared plus 6. So that's our first inequality that goes in here. And then the absolute value one is going to be everything up, above or greater than. So that one's going to be a greater than. So let's look at our absolute value. So I have my vertex at 3, -4. So that means it moved right 3 and down 4. So I can write my equation from that. I also can just look at the slope and tell what the a value is going to be. So it is 1, 2 over 1. So the slope, so the a equals 2. So for this one, it's a lot easier to write the absolute value part of it because we know about these transformations and everything. We don't need to find the a value because the a value on these is just going to be the slope. We can't tell what a b value is just by looking at a graph. So the b value comes in when you just look at the equation. So then the AV function part of this is going to be y sub 2, and this one is greater than or equal to. The a is 2, absolute value, x minus 3, absolute value minus 4. So we're going to put both of those together, and our answer will be our y sub 1, which is less than or equal to negative x minus 3 quantity squared plus 6. And then we'll put our y sub 2 with that. That one's greater than or equal to, because that's above the AV, the absolute value function. And let me check this, double check here. Okay, so this is the answer. This is the system of inequalities. That is the answer to this problem.